So let's continue with the exercise 3D. Number 3, we have solved the 3C, so we move to 3H. In the 3H, the same instruction is said, express the following as a product of primes. So for the 3H, so we have this. So we use factor method as we have introduced that in the previous lesson. So what can divide 625? What can divide 625? Definitely we have the number, the digit there is 5. 5 hence the digit. 5 hence it there. That shows that 5 can divide it without any remainder. 5 is a factor, meaning it's a factor and also a prime number. So it is a prime factor. So we said 5 in 6, 1. Remainder 1 in 12. 5 in 12, that gives us 2. Remainder what? Remainder 2. So in 25, we have 5. So 5 can still divide it because these numbers still have 5 at the end. So 5 in 12, we have 2. Remainder 2 in 25 is also 5. Definitely 5 in 25 will also give us 5. Then 5 in 5 will also give us 1. Therefore, we have for 6 to 5, we have 5 times 5 times 5 times 5, which is equivalent to what? 5 to the power of what? 4 in index form. In index form. So the other one is the 3K is 729. 729. How do we also do this? What number can we use that is said to be a prime number and also a factor, meaning a prime factor? Can we use 2? When you look at it, the 2 cannot be used here. 2 is not, the number is not divisible by 2. How do we know? Because the last digit is not 0 or even number. But when you look at the 3, the rules of 3, adding the digits will give us a number that is divisible by 3. Let's see. 2 plus 3, 7 plus 2 is 9. 9 plus 9 is 18. And definitely 18 is divisible by 3. So 3 can be used there. So say 3 in 7, 2. Remainder 1. In 12, 4. 3 in 9, 3. Can we still use 3? Yes, when you add it, 2 plus 4 plus 3, that is 9. Meaning 9 is divisible by 3. So 3 can still be used. 3 in 24, 8. Then 3 in 3, 1. Can we still use 3? Yes, 8 plus 1, that is 9. So 3 can be used. So 3 in 8, 2. Remainder 2 in 27, in 21, that is 7. Can we still use 3? Yes, of course, we can. So 3 in 27, that gives us 9. 3 can also go in 9, yes or no? 3 in 3, 1. So we now have all this to be 3 times 3 times 3 times 3. How many 3s? 1, 2, 3, 4, 5, 6. Times 3 times 3. We have 3, 6. 6 3s. So that is 6 to the power of 3 to the power of 6. And that is our answer in the index form. Now the last but not the least is 7,290. So what can be used here? Definitely we can use 2. We can use 2 is a prime factor of this number. So we can use 2. So 2, because the last digit is 0, 2 can be used. 2 in 7. So we say that is 3. Remainder 1. In 12, that gives us 6. 2 in 9, that gives us 4. Remainder 1. In 10, we have 5. Can we still use 2? I think the answer is no, because the last digit is not 0 and the last digit is not even. So what can we use? Can we use 3? So let's sum up the digits. 3 plus 6, 9. 9 plus 4, that is 13. 13 plus, that is 18. So 18 is also divisible by 3, meaning 3 can be used. So 3 in 3, 1. 3 in 6, 2. 3 in 4, 1. Remainder 1. In 15, that is 5. Can we still use 3? I think yes. When you multiply, when you add everything together, it will give you 9. And 9 is divisible by 3. So 3 in 12. 3 in 12 is 4. 3 in 1. 3 in 1 is nothing but 0. Remainder 1. And 3 in 15, that is 5. Yes, some students make mistakes by saying 3 in 15. If you say 3 in 15, you have made a mathematical blunder in that level. So what is expected of you to say is that 3 in 1, 0, then it will mean that 1. Or to play safe, if you can withhold it, you can say 3 in 121. But that may be too big for you. But it is better you say 3 in 12 than 3 in 1. When you say 3 in 15, it will be 45. And it is not 45 threes that makes 1,215. So it is 405 threes that makes 1,215. So note that aspect. So can we still use 3? Yes, we can. 3 in 4, 1. Remainder 1. In 10, 3 in 10, we have 3. Remainder 1. In 15, we have 5. Can we still use 5? I think the answer still is yes. Can we still use 3? Yes, we can still use 3. We can use 5, but let's begin to be using 3. Let's make it in an order form. 3 in 13, that is 4. Remainder 1. In 15, that is 5. We can still use 3. 3 in 45, that is what? 15. 3 can still be used. 3 in 15, 5 can still be used now. No, so we use 5. 5 in 5, we have 1. So we now write all this down. We write all those down, and that is, we have 2. How many 3s? 1, 2, 3, 4, 5, 6. 6, 3. Then the 5. So write them in index form. 2 to the power of 1, or it's just like 2 only. Then 3 to the power of what? Of 1, 2, 3, 4, 5, 6. To the power of 6 times 5. And that says it all. Thank you for listening and watching my page. Bye.